Hello everyone. I'd like to inform you all that I have completed the task 1 of the Let's Grow More internship, and the title of the task was Iris flower classification. So here in this task I have done the classification of iris flower. You can see that there are four features. They are sepal length, sepal width, petal length, petal width. On the basis of these four features, we have classified this flower into three classes. They are Iris setosa, Iris virginia, Iris versicolor. And I would like to inform you that the data source has came from Kaggle. You can also go and download it. And I have used these three classification techniques: k nearest neighbors, name based classifiers, decision tree classifiers. So in this step 1, you can see that I have imported all the library here. All the library has imported here. They are pandas, matplotlib, sklearn. They are very important library when you are doing data science project. And I have also imported numpy and seaborn. Seaborn is also a kind, it's made at the top of matplotlib, so it's also used for visualization. So here with using this command, I have imported dataset. It was in my local machine, but you can also import dataset when it's hosted on some website. There is different technique for that. You can see that uh, in internet. So here I have printed dataset. We know there is four features: sepal length, sepal width, petal length, and petal width. And on the basis of these four features, we have classified it on setosa, virginia, and versicolor. So using this dot shape, you can view the shape of the dataset here. Here at above this, you can also see that there is 150 rows and 5 columns in our dataset. And by using this command also, dot shape also, you can also view this dataset rows and column. They are 150 and 5. And so this iris dataset dot species dot value count, this command here, I have used this command. Why this command is used? For the this command iris dataset species used to fetch a single column. You want single column, so I wanted the column species. I have fetched this column using this command. And now what does this value counts do is that it counts the unique value that you want, unique value on that column. Like there was 50 unique value, iris setosa, and there was 50 iris versicolor, and there was 50 iris virginia. So with this command, you can easily calculate the how many value are present there, unique value are present there. Now if you use this dot describe, you can see that it will describe all the things. Like it will count how many data, how many petal width data are there, petal length data are there. It will bring out the mean, it will bring out the standard deviation, minimum value, and 25%, that's quartile first, and all these quartiles again, and max value. So in summary you could understand that this is the statical descriptions of your data. So I have moved to scatter plot. At first I have plotted my data, I have plotted in scatter form. So I have used matplotlib, as you seen above, that matplotlib is imported by using plt. So I have used this plt function and scatter function to plot the data. And at first I have plotted the data for iris setosa. For iris setosa, what is first iris setosa, I have put this iris setosa on setosa. I put this iris virginia on virginia, and virginica and in virginica, and this versicolor in versicolor. And now I have plotted all these. In scatter plot. So you can see here in scatter plot, iris setosa has a sepal length and sepal width. We have plotted on the basis of, we need to understand that we have plotted on the basis of sepal length and sepal width. So sepal length and sepal width of every species, every class is printed here in this graph. And similarly, I have plotted petal length, and on the basis of petal length and petal width. And now you can plot all possible combination of pairs of your features using SNS, using Seaborn. Here these are the all possible combination, like sepal length, sepal length, and sepal width, and how it all vary on the basis of your species. So you can use very simple command, very simple script for plotting this. And now you can see that I have used heat map. I first used correlation, found correlation between those all these features, and then I have plotted these correlations on the heat map. So I hope you must all know the meaning of correlation. It's the relation between two features, how the two features are connected to each other. If the correlation is positive, if the correlation is more than zero, sorry, if the correlation is more, it means that one increase when other increases, and similarly. Now we have come in step 3, where we have to split the data into training and testing set. So what we have done here in the script is that we because we need only features from our dataset. Our dataset also contains species. So for features, for X, we do not need species. So by using this script .dataset.species, we have removed the species column. Here we are removing a column. That's why we have used axis equals to 1. Otherwise we should have to use axis equals to 0. And now we have in X we have all those features only by removing spaces, but in Y we need only spaces because it's our class. That's why we have taken this on Y. Now you can see that we have the class whose name is which is categorical data. So we must have to convert our categorical data into integer data. That's why there are two techniques to convert these things into a numerical data. First is one hot encoding and the other is label encoder. We have only used label encoder here for the conversion. So we have encoded we have created an object for label encoder here, enc object. Now using this enc object we have transformed our data into encoded data. Now our Y is in the form of 0, 1 and 2, where it was in the form of the name, that is Virginica, versicolor and setosa. Now we are on step 4, and now this is the final step where we have splitted our data into training and testing set, and the size of the test set is 0.3. that is 30% of our data has converted into testing set, and 70% of our data is in the training set. Now it's the last and the main part of our project, of my project. So at first I have used this naive-Bayes classification, and here you can see that I have fit this X train and Y train, and now using this classification dot score we have test the accuracy. There are many ways to testing of the accuracy, but we have now here used the dot score method. So we have found accuracy 97.7%. So again we have used k neighbor and we have fit it and we have found the same accuracy. Now on the last part we have used distant tree classification for the classification, and here you can see the score is still 97%, and we have seen a beautiful tree that is generated that is generated in decision tree classification. Thank you for this, and please visit my GitHub and don't forget to put a star on it if you like my video.